Let's learn SN1 mechanism of the nucleophilic substitution reaction. We will proceed with the types of mechanism, then we will learn the mechanism steps of SN1 reaction with examples. We have already seen that at A-level chemistry we will be learning about two types of reaction mechanism, that is electrophilic and nucleophilic, and each of these mechanism are again of two types, addition and substitution. Even nucleophilic reactions are of two types, addition and substitution reactions. And nucleophilic substitution reactions are of two types, SN1 and SN2 reactions. So in this video we will learn about SN1 mechanism, which is followed by tertiary compounds. And in our earlier video we have already seen SN2 mechanism, which is followed by primary compounds. Now let's first understand what do we mean by nucleophile. Nucleophile is a donor of pair of electrons. So it's a species which should have an extra lone pair with a negative charge, which can react with a carbon carrying a positive charge or a partial positive charge, and it is also bonded to some electronegative atom like chlorine or hydroxide or any other electronegative atoms. And we call this reaction as a substitution reaction because the incoming nucleophile is going to replace out the electronegative atom from the tertiary compound. When we have such a compounds in which a carbon is bonded to electronegative atom like chlorine, so obviously chlorine gets a partial negative charge and carbon gets a partial positive charge. And when such compound is bonded, such carbon is bonded to three other carbon groups, then such a compound is called tertiary compound, because the carbon carrying the functional group is bonded to three other carbon groups. Now these groups, here we have taken the example of methyl groups, but it can be any other carbon groups like ethyl, C2H5, or it can be propyl also, or any other carbon groups, and such a compound is called tertiary compound. Now, such compound undergoes SN1 mechanism, and we call it as 1 mechanism because in this mechanism at a time such a carbon is bonded to only one of the reagent or one of the nucleophilic group. Now let's understand the mechanism with all the partial charges, full charges, curly arrows and all the steps. Let's first start by understanding the partial charges on such compounds where chlorine here as an example is given. Carbon has a partial positive charge and chlorine has got a partial negative charge. When such a reaction takes place, the bond of chlorine and carbon gets broken off, and the pair of electrons which is forming this bond is taken off by chlorine because it is a electronegative atom. So here you can say that an heterolytic fission of the carbon-chlorine bond is happening. When such a bond is broken, then we get a intermediate carbocation, that is a carbon carries the positive charge, and as the carbon-chlorine bond is broken with chlorine carrying the negative charge because the whole bonding pair of electron is taken off by chlorine. Now the electronegative or incoming nucleophile, which is having a lone pair and a negative charge, approaches the positively charged carbon and hence forms a bond with the positively charged carbon, forming a tertiary compound. Now everybody should note down that whenever we are drawing such a mechanism, we need to show all the partial charges, full charges and curly arrows and lone pair of electrons wherever required. And also whenever we are showing such curly arrows, we should be taking care that such an arrow should be drawn from the negative charge towards the positive charge. So such small steps should also be taken care of. Now here we have taken an example of chlorine, but in its place it can be a hydroxide ion being replaced by chlorine atom. So let's see such a mechanism which will have exactly similar steps. Only difference is the incoming nucleophile and the part of the molecule which is being substituted. Now carbon carries the partial positive charge and the alcohol part of the compound, that is hydroxyl group, carries the partial negative charge, and when the bond is broken, the bonding pair of electron is taken off by hydroxyl group, and so the intermediate carries a positive charge and the hydroxyl group carries the negative charge, and then the incoming nucleophile having the lone pair and the negative charge approaches the carbon positive to form the final product. This is how you are going to draw the SN1 mechanism with all the steps, and I hope the things are very clear.